Okay, sorry about that. I accidentally hit stop in the other recording. So continuing with P3, day 2, we're talking about the definition of the principal nth root of a real number. So if we have the nth root of a is equal to b, that means that b to the n is equal to a. So if n, the index, is even, then a is non-negative, which means it's greater than or equal to 0, and b is non-negative, which is greater than or equal to 0. If n is odd, a and b can be any real numbers. The symbol, the nth root, is called the radical, and the expression under the radical is the radicand. So it's just saying, like, we can have more than just a square root, okay? So if we have a number written up there for n, our index, our root there, then we can, it's the same thing as like the square root, but now we're not looking for 2 of a kind, we're looking for n of a kind. And if n is odd, then the nth root of a will equal a, and if n is even, then the nth root of a will equal the absolute value of a, meaning it's always going to be positive, just like before with the square root. Alright, so for real numbers, a and b, where the indicated roots represent real numbers. Alright, so the same rules that we had for square roots, okay? So if we have the nth root of two things being multiplied, we can separate them as nth root of the first one times the nth root of the second one. And vice versa, if we have nth root of a times the nth root of b, then because they both the nth root and being multiplied, we can multiply them both underneath the same radical. Same thing with division. We can separate them, or if they're separated, we can put them back together as long as they're under the same radical. So let's simplify. The third root of 40. Well, 40 doesn't have a cube root, or a third root, so therefore we're going to use our factor tree, just like what we did before. So what multiplies to give me 40? Well, I picked 4 and 10. You could have picked 5 and 8, 2 and 20. So 4 is 2 times 2, and 10 is 2 times 5. Now, because we're after that cube root right there, that means we're looking for now 3 of a kind. So I'm going to do a group of 3 here, which are my 2's. So I'm going to take a 2 out for that. And this doesn't have a group, so he gets to stay underneath that radical. Don't forget the little cube root symbol. So the cube root of 40 is equal to 2 on the cube root of 5. And then B, 125 over 27 doesn't reduce. And so we can separate them. So we could say this is the same as a cube root of 125 over the cube root of 27. Because we could do our factor tree for 125, which is what, 5 times 25? 5 is prime, and 25 is 5 times 5. We're looking for 3 of a kind, so we find it's 5 with nothing left, so no radical. So the cube root of 125 is 5. And then we could do the same thing with the 27. It's 3 times 9, 3 is prime, and 9 is 3 times 3. Cube roots are 3 of a kind, so we find that the cube root of 27 is just equal to 3. And then 5 over 3 does not reduce, so there is our solution. Now here it's the definition of a to the m over n power. So it says if the nth root of a represents a real number and m over n is a positive rational number where n is greater than or equal to 2, then a to the m over n is the same thing as saying the nth root of a raised to the m, or it could be the nth root of a to the m. So what that's saying here, guys, let me put this in easier terms to understand. So if we've got, I'm going to start out with the radical. So we've got this radical, and this little number here is our root, and the big number underneath here is our base, and then we could have an exponent here. And it doesn't matter if the exponent's inside with the base or on the outside. We can rewrite that as the base raised to the exponent over the root. So if we have a fraction in that exponent, the numerator is the exponent, and the denominator of that little fraction is the root. So might want to make sure you've got that. We're going to use that quite a bit. Then where it says furthermore, all it's saying is don't forget, if you have a negative exponent, you're going to send it to the bottom, and you're going to make it into a fraction. So let's simplify 27 to the 4/3. Well, I'm going to rewrite this. Remember, this is exponent over the root. So when I do my radical, my root is 3, my base is 27, and my exponent is 4. Now, it doesn't matter if we take the cube root of 27 first or we do 27 to the 4th first. Just remember that taking the root of something is going to make that number smaller. We're raising it to an exponent, it's going to make it bigger. So I want to make this smaller first. So I'm going to do the cube root of 27 first. Well, we did that on just the other slide, but I'll do it again. So 3 and 9, and 9 is 3 and 3. Cube root, we're looking for 3 of a kind. So the cube root of 27 is 3. So I'm going to put that 3 there, but I still have this to the 4th. So I still need to do that. So then I work out 3 to the 4th, which is 81. And then here's just like what we were doing the other day in our lesson, okay? We're multiplying everything together here, so I'm going to group them. So I have numbers, so I have 2 times 5. And I have x's, so I have x to the 4/3 times x to the 8/3. So now remember, when we're multiplying, we can just multiply our numbers. 2 times 5 is 10. But we're multiplying with like bases, we keep the base and we're going to add our exponents. So we get x to the 4/3 plus 8/3. So we get 10x to the, and we need to add them together. Now, if you remember how to add with fractions, they've already got that common denominator. So you just add your numerator. So 4 plus 8 is 12 over the common denominator. And then is 12 divisible by 3? Yes. So let's go ahead and reduce that to a 4. So we find our answer is 10x to the 4th. Now, as far as adding the exponents there, guys, if you need to use your calculator to help you with the fractions, you can. I don't mind doing it. If it comes out, though, that it's a decimal answer, make sure you change it back to a fraction, okay? Don't leave it as a decimal. All right, so that's the end of P.3. Hopefully this helped you through it, and we'll look at P.4 coming up soon.